Hi, everybody. So I wanted to create a video that reviews the third chapter of our text, which focuses on arguments and critical thinking. So what I'm going to do is I'm just going to briefly highlight some sections of the text and then go into some detail about the nature of logic and the nature of arguments. What's interesting about logic is that it helps us to see that ordinarily, when we have a phrase that we use, like we say sometimes that this makes sense, or that sounds right, or this seems reasonable. We're actually, there are ways of determining whether something actually does make sense that are much more objective than the emotions that might come along with a statement like that. So, logic and reasoning and critical thinking are all about an attempt to get behind what we are actually saying when we say, that seems right, or it makes sense. So let's take a look at this scenario that's described in the text, right? And let's kind of pick it apart. And then I want to go into some depth on the nature of arguments. There are really two major kinds of logical arguments. So we'll talk about that. And then we'll talk about how to apply that to digital ethics or other topics that we might discuss anytime we're dealing with philosophy in general and ethics in particular, but even much, much more broadly. I think one of the things that you notice about nearly every topic, nearly every subject that you'll ever study is that logic is involved and argumentation is involved in that. We're trying to put together a group of reasons towards some kind of conclusion. And that's really what we're doing here. We're talking about reasons and some kind of conclusion. Now, sometimes we say colloquially, well, what's your point? Or what's the point you're making? Or my point is, well, oftentimes when we say my point is, when we refer to a point, we're talking about a conclusion, right? The business end of somebody's argument. So let's take a look at this, right? So in this scenario, you're contemplating downloading a software application that's available on a website called ShareStore, file sharing site. All right, so it's not designated as a pirate site. However, it's clear that there are some software applications that are proprietary. In other words, they are copyrighted, right? Now, you might be tempted to download that copyrighted piece of software, but then a friend, let's say, says this. Charlie tries to convince you not to download a proprietary software program using the following rationale. And here's what he says. So here's his argument. Saying downloading proprietary software where without permission from the copyright holder is identical to stealing physical property. Stealing physical property is morally wrong. Therefore, downloading proprietary software without permission is morally wrong. Okay, so we see it's obviously put in a way that is more structurally formal than we might ordinarily conversationally make such an argument. But it's basically the idea that he might say something like, "Well, actually, downloading that is wrong because it's identical to stealing physical property, right?" And now notice here, we'd say stealing physical property is morally wrong. That's something that connects the two ideas. Downloading proprietary software is stealing. Stealing is wrong, right? Therefore, downloading proprietary software is wrong, right? So we see the structure of the argument there, hopefully. So now I want to go to a different screen here, and I've got this kind of writing implement. So I'll try to show you how we might um, look at the way an argument is organized, right? So I'm going to write something like download D will refer to downloading proprietary software, right? Without permission. It is S, right? So now D, which is downloading proprietary software without permission, is S, and S might mean stealing, right? And stealing is wrong, right? We might say D is S and S is W. S is wrong. And now we might say, therefore, D is W right there, right? So uh, downloading proprietary software without permission is stealing, and stealing is wrong. And so downloading proprietary permission is software is wrong. Okay, so one of the things we can do, so this is the structure. So another way of putting this is by saying D implies S, and S implies W. Therefore, D implies W, right? That's another way to put a logical argument, right? So if we say another way of stating this is if D, then S. If S, then W. Therefore, if D, then W. This is exactly what we see in front of us. So this is actually a valid argument. So let's talk a little bit about what we mean when we refer to valid arguments, right? A valid argument is an argument where the conclusion necessarily follows from the premises. So in many kinds of classical arguments, you've got, say, premise one, so some sort of statement, all right? And then you might have premise two, which is another statement. Let's call the first one statement A and the second one statement B. And then you've got some kind of conclusion, all right? All right, so an argument is valid, and I'll put it in green, valid if and only if the conclusion necessarily follows from the first two premises. If the conclusion necessarily follows. All right. So now in this case, we'll go over an argument that is valid, and then we'll go over an argument that's not valid. Okay. So let me show you this. Let me see if I can work this out here. I can't really quite. There we go. Let's try and erase. Okay. Sorry, I'm new to this. Go to the big one. Go. Oops, I want to erase. I just started using this whole thing. Okay, screw it. Wish I could wipe the screen. Is there a way to wipe the screen? Okay. No. Brush. Okay, there we go. Okay, I just had to go out of there. Okay, so let me give you an argument, and I'm going to structure it in a way that first is valid, but then I'm going to show you, I'm going to modify it a little bit so that you'll see, I think, that it becomes invalid. So here's premise one. Oops, sorry about that. Back to what did I have before? I had this. I had this, and it was black. Okay. So premise one: penguins, and let's just kind of assume all penguins. Penguins are birds. Right? I like to use this illustration. Okay, and then statement two: Chilly Willy is a penguin. All right. Three, therefore, Chilly Willy is a bird. All right. So we see penguins are birds. Willy is a penguin, and therefore Willy is a bird. Right. So let's. I'm going to look at this structurally here. Right. If I were to say that here's the set of all penguins. Right. Here's the set of all penguins. All right. Now, if I said that penguins are birds, and assuming all penguins are birds, then I might do this. Here's the set of penguins inside here, and then here's the set of all birds. Right? So we notice the entire category of penguins is inside the category of birds. So everything that's a penguin is also a bird. Right? Now notice it's possible for there to be something here that is a bird, but not a penguin, right? So outside of here, this is outside of category P is not P, right? Now outside of this area would be not B, right? Okay, because that's outside of the category of B, and this here is outside of the category of P. All right. So, but if we see that if something is a penguin, then it is a bird, right? Okay, so we said if it's penguins, then it's a bird. Well, Chilly Willy is a penguin, so we could put Chilly Willy here, right? So here is Chilly Willy. Let's put a W for Willy, right? Here's Willy, and Willy is a penguin. Therefore, Willy is a bird, right? So using this kind of Venn diagram structure and illustration, we can see that it's valid that if Willie is a penguin, then Willie must be a bird. It necessarily follows that Willie is a bird if Willie is a penguin. Right? So that's one of the things that we mean by a valid argument. The conclusion must be true. Okay. All right. So now I'm going to show you an example of an invalid variation of that argument. Right. Let's start with the same thing. With same first premise. All let's say all penguins are birds, right? All P are B. P means penguins, B means birds. Okay, so 2. And if I say Willie is a bird, right? Then could I say, therefore, that Willie is a penguin, right? All right, now let's look at this a little bit carefully, right? So I say all penguins are birds. Willie is a bird. Therefore, Willie is a penguin? Okay, now, it still may be that Willie is a penguin, right? It still may be. But that Willie is a penguin does not follow from the first two premises. We see that all penguins are birds, and Willie is a bird. That's the second statement. Therefore, Willie is a penguin. We can't get that therefore. That therefore is not guaranteed. It doesn't necessarily follow. So this argument, even if all of these both of the premises 1 and 2, even if they are absolutely true, and even if the conclusion is absolutely true, this is still not a valid argument. Right? So let's go back to the Venn diagram to see why that is. Right. So let's kind of reproduce what we had done before. Here is all penguins. Right. Okay. And here is all birds. Okay. All right, now what we've just said is that Willie is a bird, right? We've said Willie is a bird. So Willie he could be in this area or he could be in this area. We don't know. All we know from the premises is that Willie is a bird. So we don't know whether Willie is a penguin. I'm going to put a question mark here. We don't know that from the premises. So the conclusion that Willie is a penguin is not valid. Right? It's an invalid conclusion. All right, so this is pretty important. Let me give you another example of an invalid argument that is fairly typical, right? So let's say I do this, and this is probably maybe the last invalid argument or valid versus invalid argument that I'll offer, and we'll see, I think, fairly quickly why the first rendition is valid and the second rendition is not valid, right? So if I say if it's raining, rain. Oops, let me redo that because that was kind of messy. 1. If it's raining, then there are clouds in the sky. If it's raining, then there are clouds in the sky. Okay, that could be the first premise. 2. It is raining. Okay. 3. Therefore, there are clouds in the sky. Okay. All right. If it's raining, then there are clouds in the sky. It is raining. Therefore, there are clouds in the sky. All right. So again, we can do the Venn diagram again, right? So here's all situations where it's raining, and in every situation where it's raining, there are clouds in the sky, right? So if R, then C, we can put it that way. R implies C. That could be statement 1, statement 2. R is true, therefore C is true, right? Rain implies clouds. Rain is true, therefore clouds are true. All right, let's go back to the other argument. This argument. Now, what if I keep this and I say uh, if it's raining, then there are clouds in the sky. What if then I say 2, it's not raining? Okay. Then could I say that there are no clouds in the sky? Not R, not C. Could I say that? And now I think we all know, kind of by observation, that there are lots of cases where there are clouds in the sky, and yet it's not raining. So does it follow that if it's not raining, that therefore there are no clouds in the sky? It does not follow, right? So and again, we can do the Venn diagrams here as well. So we've got the first premise, R, therefore C, right? If R, then C. But then if I say not R, well, where am I when I say not R? I could be, so here, let's see, not R. Well, guess where else is also not R? Not R. Now this is also not C, right? So, but this is C, right? So it's possible for not R to be true and for C to be true, right? So to say, so again, the invalid argument is a rain implies clouds. 2, but no rain, not R. This is a not symbol. 3, therefore not C. That does not follow, right? This conclusion here does not follow from these two premises. Okay, so this is another example, and the Venn diagrams will really help you identify whether an argument is actually structurally valid. Okay. Now this, everything I've been describing so far, these are all ways of thinking about deductive arguments. You could think of deductive arguments like puzzle pieces, right? They are, where you have some information and then the conclusion necessarily follows from those pieces of information. Now there's another kind of argument that we oftentimes talk about in logic, and that's called inductive arguments. An inductive argument is going to take, instead of having premises that lead to a necessary conclusion, we might have premises that provide evidence toward a conclusion, but might not actually prove, don't actually prove that the conclusion is true. So let me give you an example of that. This is just kind of a classic example. So there might be it's on day 1, on the sun rose, right? Let's say that. On day 2, the sun rose. And same with 3, right? And so same with days, 1 through, 1 million, the sun rose. Okay. All right. So we have lots of data. We have lots of samples. We have lots of evidence that for a sort of general idea, a general rule, and we could say with some level of certainty, though not absolute certainty, but we can say that the sun rises every day. All right. The sun rises every day. We could say that generally, right? And we might want to qualify that, right? Probably, all right? So it will probably rise tomorrow, right? So, and we end up getting a rule out of all of this evidence, right? So that is induction. Now, do we know that the sun will rise again tomorrow? We don't know, but so far, every day, the sun has risen, right? Okay, so that's an inductive argument. You're relying on many, many samples, and there's no reason not to think that the sun will rise tomorrow, and so there's every reason to think the sun will rise tomorrow. That's an inductive argument. Now, inductive arguments. We earlier, remember, we talked about deductive arguments as being either valid or invalid. So inductive arguments, we oftentimes talk about them as either strong or weak, right? So let me give you an example of that was a strong inductive argument about the sun rising. Here's an example of a weak inductive argument, right? So if I were to say that I met 3 baseball players or basketball players, either way, and they were jerks. I don't know. Let's say, all right. And then let's say I make this generalization. I say all baseball players or even if I were to say most are jerks. All right. If I were to make that step from this small amount of of exposure to baseball players, then that's a weak inductive argument. I don't really have a very large sample size. It very well could be that all of the other, what, 100 or so, and this assumes that I didn't even qualify it. It could be also be amateur baseball players, right? I didn't even say professional. So it may very well be that most baseball players are not jerks. We don't know from this information that we have, right? So this is a very weak inductive argument, right? My sample size is tiny, and so I can't then my conclusion that all baseball players, or even if I were to conclude that most baseball players are jerks, that conclusion is not warranted, right? It's not justified by the evidence that I have presented or the evidence that I've experienced, right? So that's a weak inductive argument. Okay, now another thing that we need to think about when we're thinking about arguments is not just about, so when we're thinking about deductive arguments, then we're talking about validity, right? And remember, validity has to do with whether the conclusion necessarily follows from the premises, right? Whether the conclusion must follow. For inductive, we are checking for strength. Strength. Okay. And an inductive argument is strong when you have a large sample size. Ideally, in other cases, when it's a random sample and when it's a relevant sample, obviously. You can't just kind of collect a bunch of data that's not related to what you're looking at and then say, well, because I have all this unrelated data, that therefore I can then draw this conclusion about something else, right? That's not the case. So we talked about in strong inductive arguments versus weak inductive arguments. We talked about valid deductive arguments and invalid deductive arguments. Well, something else that we need to of course, think about is what we would call soundness. A deductive argument is sound when it actually is the case that its premises are true and it's valid, right? So a deductive argument that's valid, where it has true premises, is actually sound, right? So let me give you an example of a deductive argument that's valid but not sound, right? And then I think this will help you see what it looks like when you have a deductive argument that is sound, which was the case for some of the other ones that we looked at with the penguins and birds and with the raining and the clouds, that kind of thing. So here's a deductive argument that is going to be valid, but it's not sound, right? I say um, all of my friends are male. All of my friends are male. And then if I say Joe is my friend, right? Therefore, Joe is male. Okay. All right. Now, if I say all of my friends are male and Joe is my friend, then therefore Joe is male. This is a valid argument, right? Because if the first two premises are true, then the conclusion is true. All my friends are male, Joe is my friend, therefore Joe must be male, right? Okay. But this argument is valid, but it's not sound. It's not sound because one of the premises is not true. That's the first one, right? It's not true that all of my friends are, in fact, male. I do have some female friends, right? So, um, so a this argument is valid, but it's not sound, right? One of the premises is untrue. So this is important to check as well, right? So now if a deductive argument is invalid, then it's what we call a bad argument, right? Even if a deductive argument is valid but not sound, it's still a bad argument, right? So this is interesting, right? Because let's go back to the idea of, when we say it makes sense, all right? When we say it makes sense, really we're just talking about, it feels right? It makes sense. We usually say that when we're talking about how we feel, right? Or how something seems. But with logic, we can actually determine whether something actually does make sense, right? So if I say, all politicians as are selfish. I don't know. All politicians are selfish, right? And let's say I don't know, Jim is a politician, right? Well, therefore, I might say, all politicians are selfish. Jim's a politician, so Jim is selfish, right? And somebody might say, well, that makes sense. Well, okay, it's a valid argument, right? If all politicians but it's not sound. Well, what if I were to say this? All politicians are selfish. And then what if I were to say Jim is not a politician, right? Let's change this to Jim is not a politician. So Jim is not selfish, right? So you can imagine having a conversation with somebody and they say, all politicians are selfish. Well, Jim's not a politician, so Jim's not selfish. All right. And then somebody else might say, oh, well, that makes sense, right? Or they might just go ahead and believe it, and they might think that it's a good argument. It's actually not a good argument for one of the reasons that we saw earlier, right? And again, I'll show you structurally, right? Let's see. Let's do this. Okay, here's all politicians, right? And here is things that are selfish, right? People who are selfish, right? So if I say all politicians are selfish, and then if I say Jim, let's put Jim in purple, right? And if I say Jim is not a politician, right? Well, uh, Jim could be here. Jim could be in the member of selfish things, or Jim could be here, right? Question mark, right? All I've said is that Jim is not a politician, right? So Jim not being a politician tells me nothing really about whether Jim is selfish, right? So just because Jim is not a politician doesn't mean he's not selfish, right? Based on those earlier premises. So again, we want to try to avoid the temptation to say, that makes sense, based on whether we feel that it's right. Logic allows us to actually determine whether something truly does make sense. Right. So I hope this is helpful as an introduction, a brief overview. It really should be supplemented or complemented by reading the materials in the chapter that review this exact kind of content, right? But I thought it'd be valuable to just kind of make this video and uh, elaborate on what we mean by valid versus invalid arguments, right? And then what we would also mean by um, uh, let's see, by inductive, right? Inductive arguments that could be weak or strong, right? Okay, so this is helpful. Please, yeah, again, make sure that you read the remainder of the chapter as I kind of scroll down it here. Oh, right. One more thing. These fallacies. So fallacies are fun because they are interesting, and we see them very often. And but anyway, this should be maybe the more pleasurable part of the chapter because it can be kind of eye-opening because we oftentimes will realize that we found ourselves making these errors. Let me give you this one, or go over this one from the chapter. Edward, and this is based on a fallacy called ad hominem. Ad hominem literally means at the man or at the person or towards the person. All right, hominem means human, and ad is toward or at or against. Okay, so here's one. Edward Snowden was not a whistleblower, right? But rather a self-serving narcissist who was more interested in promoting himself than in exposing any wrongdoing, right? Also, he's reported to have lied both to his employer and his girlfriend. So how could anyone possibly believe that Snowden's leaking of the sensitive NSA documents was morally justified, right? So take a look at this argument, right? The argument is not evaluating whether Snowden's actions were morally justified based on whether they actually violated any moral principles. It's not doing that. Rather, it's performing some kind of character assassination on him. It's discrediting his personality instead of actually trying to determine whether his actions as a whistleblower were morally justified. Right? So we see that, and we do this a lot. Where oftentimes somebody makes an argument and we'll say, well, this person is made the argument in a very haughty way, or the person stumbled over their words, and so I don't believe their argument. Well, that's not a very good reason to disbelieve an argument, right? Um, there are some cases where somebody might be a professional or an expert, right? And they might make a certain argument about something that they happen to know a lot about as an expert. But if that person is perceived as arrogant, then somebody might say, well, they're just conceited, and so I'm not going to believe their argument, or I'm not going to believe what they have to say. Well, that's a problem. That's an ad hominem rejection, right? You're rejecting the person's argument because you say you don't like the person, or the person seems arrogant. But that's not a good reason to reject the argument. The argument should be evaluated, should be assessed based on its own merit, not based on the credentials or the personality or the character of the person making it. Now, of course, there may be, in some cases, some exceptions. If the argument is itself about the person's character, then sure. But in this case, we're not talking about Edward Snowden's character. We're talking about whether his whistleblowing was justified, right? Because how could anyone believe that Snowden's leaking was morally justified, right? That's the conclusion, right? Basically, that Edward Snowden's actions were not morally justified. But the conclusion is based on, again, stuff that just knocks his character, rather than whether his actions actually were morally justified. Okay, think about all the different times that we've rejected arguments based on our sense of a person's character. We do that a lot, and unfortunately, it leads to a lot of mistakes. Sometimes arrogant people make very good arguments. Sometimes people who are, say, ignorant about something are actually correct, right? And we need to remember that, right? We need to pay attention to the argument itself rather than the person making it. So anyway, enjoy these other fallacies, right? Go ahead and read them on your own time. And again, one of the reasons why they're so pleasant to read is because we might see ourselves having made these mistakes before. Also, I want to say this overview of some fallacies is tiny compared to the list of, compared to all the fallacies we can actually make. There are tons of logical errors we make regularly. So knowing them and understanding or seeing this list of fallacies will help us to spot them more easily and to avoid them more easily, which is certainly what we want to do as we hone and develop our critical thinking skills. All right, thanks very much, and I hope you are enjoying this class so far, and hope that you'll continue to participate and stay engaged. And I will keep you updated on the upcoming tasks and everything that you need to do over this next week and then the forthcoming weeks. And please email me if you have any questions or concerns, and I will respond. All right, thanks, and take good care.